Hello everybody. In this video we'll be covering one of the sections in Chapter 2 of our textbook Introductory Chemistry by Tro. This chapter is titled Measurement and Problem Solving. So now that we know that measurements involve writing quantities that are going to involve a number and a unit, I want to talk a little bit about scientific notation, which is a way that scientists use to write specific numbers sometimes. That is a little different than maybe some of the other ways that you've seen it written before. So scientific notation is used to write really big and really small numbers. And these can wind up popping up a lot of the time in science because sometimes the numbers we use just don't really fit well in our base 10 system. We commonly measure objects that are many times larger or smaller than our standard of comparison. And writing large numbers of zeros is tricky and confusing. You know, if you had to sit there and write out 23 zeros and then a 2, you might, it'd be difficult and obnoxious really to do that. And also there is often a limit on your calculator. Okay, your calculator may not even accept a number that exceeds 8 digits, or even if you had a graphing calculator, something of a limit like I think it's 32 or 64. So some examples of really large numbers. The sun's diameter is 1,392,000,000 meters across. And a really small number, an atom's average diameter is only 3 billionths of a meter across. So scientific notation. In scientific notation, each decimal place in our number system represents a different power of 10. So this is just a fact, right? 0.1 is 1/10, 0.01 is 1/100th, so on and so forth. Scientific notation writes the numbers so that they are easily comparable by looking at the power of 10. So some examples of previously and how we would write them using scientific notation. We're going to write that the sun's diameter is 1.392 times 10 to the 9th meters. Okay. And an atom's average diameter is 3 times 10 to the negative 10th meters. Doing this, we can more easily directly compare them, and we'll talk about that in just a second here. So exponents. When the exponent on the 10 is positive, it means that the number is that many powers of 10 larger. Okay, so 10 to the 0 is 1, 10 to the 1 is 10, 10 to the 2 is 100, so on and so forth. So increasing an exponent here is going to mean that the number is larger. For instance, here we have that the sun's diameter is 1.392 times 10 to the 9th meters. If we expand this out, that means that we have 1.392 times 1 with 9 zeros after it. Okay, so that's going to be 1 billion meters. And if we do this multiplication out, we get back to the original sun diameter that we saw before. And this is our decimal notation here. When the exponent on the 10 is negative, it means that the number is that many powers of 10 smaller. Okay, so again, 10 to the 0 is 1. 10 to the negative 1 is going to be 1 over 10 or 1/10. 10 to the negative 2 is going to be 1 over 100 or 1/100th, okay? Or 0.01. So if we go back to our example of the average atom's diameter, we have 3 times 10 to the negative 10th. This means that we're going to have 3 times, there's going to be 9 zeros here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and that's because 10 to the negative 1 would have been 0.1, right? So you don't start adding zeros in this case until you get to 10 to the negative 2, which is a little something that you should pay attention to when you're thinking these things through. okay? And that's going to get us back to our original value for the diameter of the atom. So let's talk a little bit about how we're going to compare numbers. So comparing numbers that are in decimal notation is something we've done for a really long time. You can tell which number is larger than another when you've seen it in the regular decimal notation we're used to. But there's a couple of little caveats when you're doing it in scientific notation, but it actually makes it pretty easy. So the first thing we're going to do is compare the exponents on the 10. Okay, if the exponent on one of the numbers is larger than the exponent on the other one, you're done. Okay, that's the larger one out of the two. All right. It's only if those exponents are equal that we need to even look at the decimal numbers in this case. So for instance here, if we diagram this out just so that we know what we're all talking about, the exponent is going to be -8. The exponent part is this 10 here. This whole part here is the exponent part. And then we have the decimal part here. So the first thing we're going to do is we're going to look at this exponent, and we can just ignore this. And only if these two are the same do we even need to take a look at this. So let's look at a couple examples. In this one, we have a 5 here, and we have a 2 here. I don't even need to look at the decimals. I know that this one is larger, and I can write the larger than symbol here. In this example, we now have negative exponents, and there's something of a caveat here that people get a little confused about sometimes. Okay, here we have -2 and we have -5, and some people will want to say, well, 5 is larger than 2, so this must be the larger one. But that's not true when we have negative numbers, right? -2 is less negative than -5, therefore -2 is a larger number when we're dealing with negative numbers, right? It's further to the right if you drew out a number line. Therefore, this is the larger value. And now in this case, we have the example where the two exponents are the same. And now we have to take a look at their decimal values. Okay, so we see that 7.89 is larger than 1.23, so therefore this is the larger number. So let's go through the steps of taking a decimal value and writing it in scientific notation. So the first thing we're going to do is we're going to locate the decimal point. Then we're going to move the decimal point to obtain a number between 1 and 10. Okay, so we want a number and then a decimal place. We're going to multiply the new number by 10 to the n, and in this case, n is the number of decimal places you move the decimal point. If you move the decimal point to the left, then n is positive. If you moved it to the right, then n is negative. If the original number is 1 or larger, then n is positive. If the original number is less than 1, then n is negative. Okay, so these, don't get confused here. These are really saying the same thing. Okay, if the original number is 1 or larger, then that means that you had to have moved the decimal place to the left in order to write it between 1 and 10. Okay, and if the original number is less than 1, you would have had to have moved the decimal place to the right. Okay, so this is the same thing, just written in two different ways, and two different ways of kind of thinking about it. So let's take a look at an example. If we have the number 12,340, first thing we're going to do is locate the decimal place. Now it's not written out, but I know that it's right here, right? When it's not written, it's right past the last number there. So I can write it out with the decimal place there. Next, we're going to move the decimal point to obtain a number between 1 and 10. Okay, so if I move it here, I'm going to have 1,234. That's not between 1 and 10. If I moved it here, I'd have 123.4. That's not between 1 and 10. If I moved it between the 2 and the 3, I would have 12.34. That's not between 1 and 10. So I'm going to need to move it right here in order to obtain a number between 1 and 10. Now we need to multiply the new number by 10 to the n, where n is the number of places you moved the decimal place. Okay, so we moved it over 1, 2, 3, 4 times in order to write out that number. And we get 1.234 times 10 to the 4th. Okay, now we need to decide if this exponent is going to be negative or positive. So if you move the decimal place to the left, which is what we just did, then n is positive. If you moved it to the right, then n is negative. So we also know that this number was larger than this number. And again, according to our rules, that means that this is going to remain a positive. And our final number is going to be 1.234 times 10 to the 4th. Let's take a look at an example that goes the other way. All right, so now we have basically the same number, but it's now a fraction, right? The first thing we need to do is locate our decimal point. This time we hadn't written it out explicitly, so that's a pretty easy step for us this time. It's right there. Now we're going to move the decimal point to obtain a number between 1 and 10. So that means we're going to go here. We're going to go 1, 2, 3, 4 in order to obtain 1.2340, right? So again, it looks the same as what we had before. That is just kind of a coincidence in the numbers that we've chosen though. We're going to multiply the new number by 10 to the n, where n is the number of places you moved the decimal place. So we moved it 1, 2, 3, 4 places. And again, we arrive at the same thing. The caveat here is that this time we started with a smaller number and we moved the decimal place to the right, right? So if we apply our last rule here, if you move it to the right, then n is going to be negative. We see that this number is in fact 1.2340 times 10 to the negative 4. All right. So you can see how you're going to manipulate these based on what your starting number is going to be. If it's a smaller number, you're going to have a negative exponent. If it's a larger number than 1, you're going to have a positive exponent. Okay, so let's think now about how we're going to go the other way. If I'm given a number in scientific notation, how I'm going to write this number in our decimal form, or what's also known sometimes as the standard form. So let's start with a number in scientific notation. We have 1.234 times 10 to the negative 6. The first thing that we need to think about here is that since the exponent is negative 6, we need to make the number smaller by moving the decimal point to the left 6 places. So you would have had to move it to the right when it was initially in decimal format, okay, to get it into scientific notation. To reverse that and go back to decimal form notation, we're going to need to move it over to the left. We're going to need to make this number smaller because this is a negative number. And when you run out of digits to move around, you're going to need to add 0. So if we make one move here, we can do that. If we make another move, what do we do there? We're going to add a 0. The next move, we'll add another 0. And we'll add as many as we need to in order to be able to move this over 6 places. And we're going to add a 0 in front of the decimal point for decimal numbers. This is really just it's not a hard and fast rule. I've actually seen other places where they say not to do that. But as a matter of taste, I usually add a leading 0 in front of my decimal places too. I think it just makes the number a little bit more clear. So if we did it all out, we would wind up with this number, right? Because we've moved it over 1, 2, 3, 4, 5, 6 places, stuck our decimal place there, filled in all the zeros that we needed, and then placed that 0 in front of the decimal point in order to write this out. So let's take a look at an example here. The U.S. population in 2007 was estimated to be 301,786,000 people. Express this number in scientific notation. I'll give you guys a little bit of a second to work that out. So if we work that out, we would see that this is 3.01786 times 10 to the 8 people. So we would have moved this over 1, 2, 3, 4, 5, 6, 7, 8 times. We would have written out that number here. We're not going to include the zeros at the end when we write out this decimal, okay, because we do not need those in this case. Although we do need the middle one, right? Because we can't write this number without that one. Times 10 to the 8th. This 8th is going to be positive because this is a larger number than 3.01786. Here is a few different ones for you guys to practice. You can pause the video now and give those all a shot. Once we work them all out, we can see what all of the answers are here. If you, for instance, this first one, we would have moved this over 1, 2 places, written out that decimal, and then put 10 to the 2 on it because, again, this is a larger number. Here we can see again that we do not include the zeros at the end when we're writing out our scientific notation. And then if we start to move over here, we can get an example where we already had a decimal that was between 1 and 10, and then we wound up writing that 10 to the 0. This is really a pretty silly thing. It's just to kind of show you how that would have worked out. Because scientific notation is usually used for large and small numbers, you're typically not going to write something like that out. You would just write it as 8.0012. But if you were pressed to write this out in scientific notation, this is what it's going to look like, because 10 to the 0 is 1, and any number times 1 is itself. And over here, we have the smaller values with their negative exponents. And again, we're not going to write out these leading zeros here either, just the 2.34 that we need. Here is an example where we can practice writing these out starting from scientific notation to standard form. Again, I'll give you guys a second to you can pause the video and work those out. And here we can take a look at what the answers are. We have a positive exponent here, so this is going to be a larger number. We're going to move it over 1, 2, 3, and we're going to fill in those zeros where necessary. Here we have a negative exponent. We're going to get a smaller number, and we're going to add in zeros at the beginning where necessary, and we're going to put a 0 in front of our decimal place. Again, that is just a matter of taste, but it's something that I think that we should be doing in this course. And then you can see that pattern repeated here. And then over here, we have another example where we started off with what it seems kind of like a silly scientific notation, but you can see that that is just going to remain the decimal value, because again, 10 to the 0 is 1. Here, we can see that we're getting larger. And again, we're going to maintain the same value. So there are many different kinds of calculators, but I did want to give you guys a little bit of a taste on how you can put your scientific notation into a calculator. And I'm starting here with a kind of a standard scientific calculator. Typically, you're going to input the decimal part of the number, so this part right here. And if it's a negative, like in this case, it's negative 1.23, okay? You typically don't start by pressing the minus key, okay? On most scientific and graphing calculators, there's a separate key that changes the sign of a number. And it usually looks something either like a plus/minus key or a negative symbol inside of some parentheses. This is separate from the minus key. And it's because the digits are saved as what they call unsigned longs in computer science, and so they have a sign that's associated with the number. And you need to kind of specify that by pressing one of these keys. And although if you just put in the decimal, it's going to take it as a positive initially. So it's only really if you have a negative that you need to press that button. So once we have this decimal part, we need to then tell it that we're going to add on our exponential part. And usually there's a button for that, and it says EXP for exponent, or it says EE, which stands for exponentially expressed. It depends on which kind of calculator you have. And like, for instance, the Texas Instruments, the TI ones, I've seen both of these on there. If you have a Casio, I typically see it as EE. But you're going to press that button, and then it's going to usually have like a space and then some double zeros here where it's saying input what this exponent only is. You're not doing 10 the times 10 to the 10 here. It's just saying what is this exponent. And then you're going to go ahead and you're going to input the exponent, and again you have to change its sign using this key here. So you could have 10 to the 3, or you could have 10 to the -3 here. Some calculators are nice about letting you input the value and then change its sign by pressing the key. Some of them want it in a specific order, either to press the key and then input the number, or to input the number and then press the key. It really depends on how yours operates. So if it doesn't want to do it one way, try it the other way. So if you have a little bit more sophisticated calculator, like for instance the Texas Instruments graphics calculator, the process is a little bit more different. What they try to do is allow you to kind of input a little bit more about like the way that you would write it. It's always important whenever you're using a graphing calculator or a calculator that allows you to input multiple steps at the same time, to always use your parentheses liberally. What that does is just help to ensure that the order of operations the calculator's following is the ones that you intend it to do, right? Because you could wind up with a different number if it adds and then multiplies or something. If it multiplies and then adds, but you wanted it to do something different, you need to make sure you're being very explicit with the calculator. Type in the decimal part of the number. So we're going to type that in here. Again, there is a separate button that's going to allow you to put in a negative. All right. Then you're going to press the multiplication key, which is going to add this little asterisk here. Okay. Asterisk in these type of calculators is in the place of this multiplication symbol. Then you're going to type 10. Okay. So you're explicitly putting in the 10 there, right? And then you need to express that you're going to be entering in an exponent. And the way that you do that on these type of calculators is with this symbol here called a caret. It's the one above the 6 on your keyboard. And you're going to put in that caret. What the caret means is that everything after that is going to be an exponent. And then you're going to type in your exponent. And again, you're going to need to use a negative sign if you have a negative exponent. Okay. Now, if you use the minus sign when you're entering in these values here, it's going to write out something that looks a lot like this. Okay. It's actually subtly different. Usually this minus symbol is like a little longer. All right. As opposed to the negative symbol when you're typing the negative button. But then when you go to hit enter, it's going to give you a syntax error. Okay. So if you're seeing the syntax error when you're writing out numbers like this, what you might be doing is hitting the minus button instead of the negative button. So keep that in mind.